Hello and welcome to my 11 plus maths problem solving session. Let's work out the answers together. The question here is a map of the roads in Lancashire. So we have all these places here: Brighton, Aylesford, Chatsworth, Goldsworth, Foxton, Dogsville, Edgewood, Habsville Airport. And our answer has to be the routes. When we show it, has to go from if you are going from Chatsworth to Dogsville, the Chatsworth should be at the first, Dogsville should be at the end, and the roads in between comes in between, so it's like C to A to D. So then the question is, there has been a robbery in Aylesford. The thieves are planning to go to Habsville Airport to flee the country with their loot. The police want to go from Aylesford to Habsville Airport by the shortest possible route. What route should the police take? So where is Aylesford? Aylesford is here, and there's Habsville Airport. The police have to take the shortest possible route. We have the distances given, and I think what we can do is, so if we say the police go from Aylesford to Dogsville, that is 40 miles. From Dogsville to Foxton, that's 20 miles. And from Foxton to Habsville Airport, that is 50 miles. So that is 40 plus 20 plus 50. So that gives me 4 and 2, 6 and 5 is 110. So I get 110 miles. Now, if I do another route, so if I don't go to Dogsville, if I go from Aylesford to Brighton, so and then to Edgewood and then to Habsville Airport, what do I get? So I get Aylesford to Brighton is 30 plus 50, that's 80. 80 plus 30 is also 110. So both are 110. So which is quite interesting. Now if we take another route, that is Aylesford to Dogsville to Edgewood, so 40 plus 20, 60, and Edgewood to Habsville, so we get 40 plus 20, that's 60, plus 30 is 90, so we get 90, which is much shorter. So they have said they should take the shortest possible route. So Aylesford to Habsville looks like this is the shortest possible route. We can also take Chatsworth, but which is 50 miles to Chatsworth, and then 40 miles to Goldsworth, which makes it 90, and then adding 70 miles, which is a lot. So I think the answer, that is not where we want to go. We would stick to the routes this way. It's either this, the Aylesford to Dogsville to Foxton to Habsville Airport, which gives us 110, or we are going to but that is 110 is not the shortest possible route. The shortest possible looks like it's 90, which is Aylesford to Dogsville, Dogsville to Edgewood, Edgewood to Habsville Airport. So this, I think, is the route that the police would take, and this is the shortest possible route. So we are going to write, because this is 90, the other one we got is Aylesford to Brighton to Edgewood to Habsville Airport is 50 and 30, 80, and 30 is 110, so which is more. Okay, so our answer, I think we will write A, then we will write bit slow at writing, as you can understand the reason. Y to D, then we go to E, then we go to H. So Alresford to Dogsville to Edgewood to Hapsville Airport. That is the shortest possible route. Okay, that's done. The next one is the thieves also want to go from Alresford to Hapsville Airport by the shortest possible route. However, the thieves also want to make sure that they don't travel on any of the roads being used by the police. What route should the thieves take? And they want to take the shortest possible route, but they don't want to take any of the routes taken by the police. In that case, there is another way, which is 30 and 20 and 20 and 50. So if I change my pen color and if I say they go this, then this 50 and 20, they do 70 and 50 is 120. So that's what I think they will take. It's more than what the police are saying. So it's going to be to Brighton, to Dogsville, to Foxton, to Habsville Airport. So that way they don't share any of the routes with the police. They could also come down to Goldsworth and then to 70. How much will that be? 30, 20, 50 and then 60 and 70 is 130. So that option doesn't work out and they can't go any of this route because that is used by the police. So the route that they are going to take is, if I use purple now to show which route they will take, I think is this: Alresford to Brighton, Brighton to Dogville, Dogville to Foxton, Foxton to Habsville Airport. So 50, 20, 70, 20, 90 and 30, 120. So they go from Alresford to Brighton to Dogsville to Foxton to Habsville Airport. So that is this done. I am going to just make it look a bit clearer. So then next question is, we will go to the next question then. So this is the one we are now doing. For each of the prime numbers in the table, we'll find the remainder when the prime number is divided by 4 and find whether the prime number can be expressed as the sum of two square numbers. So, and then if the prime number, so what do we do? So if we write, or if it's not possible, we write not possible. So when it is divided by, they've done 2 for us. When it is divided by 7, the remainder is 3, and this cannot be expressed. So this is not possible because 1 square plus 2 square is 5. The next prime number is 3. When you do 3 square, you get 9. So this is clearly not possible. So the next one is 11. When you divide 11 by 4, you get 3 because 4 times 2 is 8. So again, this is not possible, I think, because 4 times 4 times 4 square is 16. And before that we have 3. 3 square is 9. 9 plus 1 is 10. So 1 square plus 3 square is 10. And this is 11. And 9 plus 4 is 13. So the next one is possible, which is 3 square and plus 2 square. 9 plus 4. 3 square plus 1 square is 10. So 9 plus 4 is 13. So 3 square plus 2 square. The remainder here is 1, because 4 times 3 is 12. For 17, the remainder is 3. This is also not possible. 11 we will not get as a square of two numbers, because, as I just explained, because 4 square is 16, 3 square is 9. With 9 you have to add 1, it will give you 10. With 9 if you add 4 it gives you 13, which is not possible. So the next one we have is 17, and here again the remainder is 1, because 4 times 4 is 16. So 17 expressed as the sum of two squares will give you 9 plus 4 is 13. So you get 4 square plus 1 square. Excuse my writing. So it's 4 square plus 1 square. I hope the 4 is clear. 4 square plus 1 square. I should use a better pen. My apologies for being so clumsy at this. So the answer is 17 can be expressed as sum of two squares is 4 square plus 1 square. 16 plus 1 is 17, and when divided by 4 the remainder is 1. The question they have asked here is, what is the link between whether a prime number can be expressed as a sum of two square numbers and the remainder when that prime number is divided by 4. So the relation we can see is there is a pattern here. When the remainder is 1, the number can be expressed as a sum of two squares, and when the remainder after dividing a prime number by 4 is 3, it cannot be expressed as a sum of two squares. To make to substantiate our answer, we can go to the next prime number, which is 19. And 19, when we divide by 4, we get 3, because 4 times 4 is 16, and 3 19. And if we try to express 19 as a sum of two squares, now 4 square plus 1 is 17. We can do 4 square plus 2. 4 square is 16, and 4 is 20. Plus 2 square is 20. So it cannot be expressed as not possible as a sum of two squares. So if we do 19, we again have to write not possible. So I think this is the trick here. The next one is 23. 23 we can say again 16 plus 7. I don't think so. The 23, the remainder is 3. Because 4 times 5 is 23. So in 23 it is not possible. So I think that will be written here. I'm not going to write it for you because you'll not be able to read it. So I will just say it: when you divide a prime number by 4 and the remainder is 1, then it can be expressed as the sum of two squares. That's it, folks. Thank you very much. Bye.